of these up, we're going to have one x and another x, that's two x's, and another x, that's three x's, and another x, that's four x's. So we're going to have 4x. So when we add them all up, we just get the number that we add up. When we multiply them, that's where we get our exponents. Oops. Okay. Okay, so what is different between saying x plus x and x times x? All right, x plus x would give us 2x. X times x would give us x squared. This one's going to be distance. This one's going to be area. Okay, does that make sense? You guys have any questions on that? All right, you guys, the code's up there in the corner. It is FSJKFQ. And I'll give you guys just a second to get logged in before we move on. Update attendance here. Okay. All right, so today we are going to talk about applications of solving equations. So yesterday we worked on solving equations. You guys got it? You need a second? Juan, you got in there? Yeah? Okay. All right, perfect. So yesterday we were talking about solving equations and about how do we go about finding the answer? Who can remind me, when we were talking about solving an equation, who can remind me what that meant? What were we trying to do when we were solving an equation? What were we trying to do? What are we trying to do if we solve an equation? Find the answer for x. Yeah, exactly. We're trying to figure out what the variable is going to be. Okay. What's an application? Who knows what do I mean when I say do what? So that is an application of what we're doing. Oh no. So this is going to be like an example. So like we solved equations, we found x. This is going to be the when would we do this? Why would we want to do this? Okay. So we're going to figure out like why would we do this when? Luis, good morning. How are you doing today? And Tyshawn, good morning. Welcome. Okay, let's pause 1 second here. Let's get everybody logged into the Pear Deck. Tyshawn, there is a link to the Pear Deck for you. And Luis, our code is up here. It is FSJKFQ. All right, let me update attendance real quick. And Luis. Okay. Okay, so we're going to be looking at things like that we might call like word problems. We might say, well, these are the kinds of situations that we're going to find when we need to solve a word problem. Okay. So what does that mean we're going to do today? All right, so by the end of today, we want to be able to do two things. We want to be able to solve an equation that has multiple steps. We worked on that yesterday. We're going to keep working on that today and remembering what are our steps that we have to do to find the answer for what our variable is. The other thing we want to do that's new for today is we want to be able to interpret the language in a word problem and create an equation from it. So this is what we were doing here a bit before. We were saying, okay, let's look at a problem and let's create an equation from that. We're going to combine those two things together now, and we're going to create our equation, and we're going to figure out the answer to the variable. Okay? What questions do you guys have on what we're going to do today? Make sense? Concerns? Nope. Okay. Let's see. Did everybody get into the Pear Deck? I have got Alex. So still waiting for Luis. Are you still getting logged in? Okay. Yeah. Okay. So, whoops, here in the slides, I put an example of solving a multi-step equation like we were talking about yesterday. So we've got this big old equation right here. We've got 4 times, in parentheses, 2x plus 4. So 4 groups of 2x plus 4 equals -5 plus 2x minus 9. So up here, this is our whole big equation that we're starting with here. All right, right here. Over along the side here, I've got some of the steps we were talking about yesterday. And I have this saying that we came up with to help us remember what it is that we need to do. So our saying was, who can tell me what our saying was? What is our saying? Don't call me after midnight. Thanks, Stephanie. And so our steps on there are D stands for distribute. Our C stands for combine like terms. Our M stands for move the variables to one side. Our A stands for move the constants away with addition and subtraction. And then our M stands for move our coefficients away with multiplication and division. All right, let's look at an example. Let's use this one here as an example of how we would go about this. All right, our first step is distribute. Okay, what was it? What did we talk about yesterday that was, what's kind of symbol are we looking for that's an indication that we need to distribute? All right, Stephanie's got it. Luis, what do you know? The parentheses, right? Okay, so we're looking for parentheses. So we've got parentheses right here and right here. So that tells us that we need to distribute our 4 to everything inside of our parentheses. So we're going to distribute our 4 to our 2x and our 4 to our plus 4. When we distribute, what math are we doing here? What operation? Multiplication, right? So we're going to take 4 times 2x. That'll give us our 8x here. And our 4 times 4, that gives us our 16. Okay, so we have simplified this side of our equation. 4 times the quantity of 2x plus 4 down to 8x plus 16. Okay, distributing's done. What is our next step here? Alex, what's our next step after distribute? Okay, combine like terms. So what defines a like term? How do we know if our terms are alike? What do they have to have? Juan, you and I were talking about this yesterday. What do like terms have to make them alike? Right, right, 8x. Okay, 8x and 2x, because they both have the same what? Variable. Yeah, they have to have the same variable. Perfect. So same variable. Okay, we also have to have the same exponent. So in our first problem, in our do now problem, where we had x's and then we multiplied them and got x squared, are our x's and our x squareds the same? Can we combine those? If I have 2x plus 2x squared, can I combine those? No, no. The x and the x squared are like two different things. We cannot combine those. Okay, same variable, same exponent. What if I don't have a variable? What if I've got like my 16 or my -5 or my -9? Are those things I can combine? Yeah. Because essentially they do have the same variable, right? Olivia, you're saying no, you can't combine those? What's keeping us from combining our numbers? You're right, they don't have variables, but they both don't have variables. So essentially they act as the same. So they're just numbers. If we took out our, like for example, on our right-hand side here, if we took just the -5 minus 9, those are just constants that we can do regular math with. Okay, Olivia, we absolutely did say that we do want to find the same variable and the same exponent. In this case, we're just saying no variable. If neither one of them has a variable, that's like having the same thing. They both have no variable. Okay? All right. How do I, so do I have any like terms over here, 8x and 16? No. Okay, so I can't combine anything on this side. Can I combine my -5 and my -9? Yep. How about the 2x? No. Okay, so this part is just going to drop down and stay 8x plus 16. What do I get when I combine my -5 and my -9? Okay, close. You are on the right track. This is tricky because we're working with negative numbers again. So let's draw a number line. Okay, we're gonna start here. I'm gonna put 0 here. We would go up this way, 1, 2, 3. We would go down this way, -1, -2, -3. All the way down here, our starting point is gonna be -5. Okay, so our plus direction is this way, our minus direction is this way. So if I start here at -5, and I go in the negative direction, 9, are my number, what number am I gonna get here? -14. Yeah, I'm gonna keep going this way. So I'm gonna go -5, -6, -7, -8, -9. I'm gonna keep going another 9 places in the negative direction. So I'll get down there to -14. Well, you know what? We're gonna pause here. We're gonna shift gears really quick and talk about negative numbers, because this is something I feel like we all, like, it's really hard and we all have got to think about. So give me 1 second here. I'm going to show you guys a video. Where are my... Okay. All right, I want to show you guys this.
Difficult. Here's a little trick to help you remember.
Hang on, let me start at the beginning.
With all of the rules and scenarios, remembering how to add and subtract negative numbers can be difficult. Here's a little trick to help you remember. Let's say we want to solve 3 plus negative 7. First, imagine a number line with a bird sitting on our first number, 3. The operation, plus or minus, tells you which end of the number line to look at. Since we're adding, our little bird will look right, towards the positive end. Our second number tells us how far to move and which direction to move. We'll move forward if it's positive and backwards if it's negative. Since our second number is a negative 7, our little bird is going to move backwards 7 spaces. Since he landed at negative 4, that's our answer. 3 plus negative 7 equals negative 4. Let's try another one. What about negative 2 minus negative 4? Our first number is negative 2, so that's where we'll start. Our operation is a minus, so our bird will look left, towards the negative end. Our second number is a negative 4. Therefore, our bird will move backwards 4 spaces. Our bird landed at positive 2, and that's our answer. Negative 2 minus negative 4 equals 2. Let's recap. The first number is where you start. The operation tells you where to look. Plus, right, or minus, left. The second number tells you how far to move and in which direction. Positive, forward, or negative, backwards. Where you land is your answer. That's it. You now know a trick for adding and subtracting negative numbers.
There you go. All right, what do you think? Was that helpful? It's confusing? All right. So what we want to think about, like where we start.
Today, I'm going to focus on the math section.
Oh, sorry. I didn't, thought I stopped that. Okay. So we want to think about like, where do we start and then which direction do we have to go? Okay, so that's just a little trick to help us remember that. I should make a poster on doing that. So there's not really a super great way to say if they're both positive, we do this, if they're both negative, we do this. We just have to think about where we're starting and which direction. Mm-hmm. So the more we do these, let's walk through all of those and think of let's think about how we're going to do those, and let's just keep practicing with those. And look at it. So our first number is where we want to start. If we add, we go to the positive direction. If we look towards the positive direction or the negative direction, and then if our second number is positive, we go forward. If it's negative, we go backwards. So in this case, we've got, I'm going to throw another slide in here really fast. Actually, I'm not. I'm just going to go like this. Okay. So we had -5 minus 9, right? This was the problem we were thinking about. So we've got our number line here. 0, -1, -2, -3, -4, -5. So this is our starting point, is -5. Okay, so that's our start. And now we've got a minus. So that tells us we're going to, so I'm starting here. This tells me I'm going to look towards the negative direction, right? And then since I have a minus sign here, this number is a positive. So it tells me I'm going to go forward. So if I'm looking towards my negative direction, it has to tell me I'm going to walk forward. Okay? So that means I'm going to end up going this direction. Does that make sense? Stephanie's saying, yeah. I'm not sure that they're convinced about that, though. Luis? Kinda?
What about if it was -5 minus -9?
Okay, if we had -5 minus -9. Okay, so we'd still start here at -5, right? So I'm going to start right here at -5. The minus tells me I'm going to look towards the negative direction. But since I have a -9, I'm going to walk backwards. 9 spaces. Right? So I'm going to look this direction. So I would start here, and I would look this direction. So if I've got a little guy, he's facing this direction. But he's going to go backwards 9. So it's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Back to that space right there. Right, so we'd end up at 4. No, +4, because he's already gone past -4, -3, -2, -1, 0.
What about the positive one?
Oops, ah. Oops, shoot. Okay, Stephanie, what about -5 plus 9? Is that what you were saying? Okay, -5 plus 9 is actually going to be exactly the same as -5 minus -9, except I'm going to start at 5, and now I've got a plus, so which way do I look? I look this way, and I've got a +9, so which way do I walk? This way. So I'm still going to end up here at 4. I just turned the other way, but I'm still going to end up at the same place. All right. Okay, Alex, yep. Okay, you got 4. Any others ones you want to try? You want to see what would happen? Does that kind of make sense a little bit now? If you want to come up here and pretend you're a bird and walk back and forth, you're welcome to do that too. You can practice that way. Okay, well, we'll see. We'll keep working on this. We'll keep working on remembering how we add and subtract positive and negative numbers, because it's something that I know people get tripped up on. Okay, so we'll keep working on that. Okay, so we had -5 minus 9. So we said that's going to get us here to -14. Okay, so we got our combining like terms done. And that got us down here to this equation of 8x plus 16 equals -2x minus 14. Okay, this one did these a little bit different. So let's go ahead, let's ignore these right here. If I want to move my variables to one side, how would I move my variables to one side? What are my numbers that have variables? Yep, 8x and 2x. Which one should we move? Which one, Stephanie? The 2x? Okay. So I'm going to cross this guy out. I mean, these aren't wrong. We're just going to do a little bit differently. Okay, so we are going to move our 2x. What math are we going to have to do, Luis, to move our 2x? We want to move it over here to this side so it can join up with our 8x. Do what? Division. What are we going to, add? If we add 2x to this side, we'll have 2x plus 2x. So we'll have 4x over here. Is that what we want to do? Subtract. Okay, good. All right, minus 2x on this side, minus 2x on this side. Nothing happens to our constants. They're just hanging out, waiting their turn. So 8x minus 2x is, how many x's do we have left? 8 minus 2? 6. Thanks, 1. 6x plus 16 equals, if I have 2x minus 2x, I don't have any more x's on this side, right? 2 minus 2 is going to be 0, so those are going to go away. So my negative 14 just drops down here. Okay. Now what do I want to do? Now I want to, it says I want to use addition and subtraction to move the constants away from the variable. What number, Olivia, what number do I want to add or subtract to get it away from the variable? What do I have near my variable that is a constant? Ideas? Who else can help Olivia out here? Alex? We want to know what we're going to move away from this x. What's our constant over here? $16. Yeah, our constant is 16. Okay, I see Olivia and Alex typing now. It's the number that's just sitting here all by itself. Letting Alex and Olivia finish their typing. Okay, so Olivia's saying we're gonna get rid of the 16. She's suggesting that we add this. Should we add it? If we add it, are we gonna get rid of the 16 on that side? Okay, currently the 16 is being added to our 6x. So if we want to do the opposite of that addition, we want to undo that addition. Yeah, Alex, we're going to subtract it, right? Okay, so we're going to subtract 16. Good. I'm going to subtract 16 here. I also have to subtract 16 over here because whatever I do to one side, I have to do to the other side in order to keep them balanced. All right, my 6x now here is just hanging out, waiting for its turn. So our variable is just going to drop straight down. 16 minus 16 is going to give me 0. So we can ignore that guy now. How about negative 14 minus 16? Okay, here's another one of those negative number problems. If I start at negative 14, so our problem is going to be negative 14 minus 16. That's what? Positive. Not quite. Okay, let's think about it. So we're starting, where are we going to start? We're going to start right here, right? We're going to start at negative 14. So I'm standing here at negative 14. And my positive direction is this way. My negative direction is this way. So if I'm subtracting 16, which way do I look? I look this way. Okay, and now I have a positive 16. So do I go forwards or backwards? I'm going to go forwards. So I'm going to keep going this way. So yeah, so I'm going to have 30, and is it going to be positive or negative? Negative 30. Good. Okay, negative 30. Okay, good. Negative 30. And now last step to get x by itself. Olivia, thank you for negative 30 there. Good. Last step to get my x by itself, Luis. What's my last step here? I've got 6x equals negative 30. What's my last step to get my x by itself? Okay, I have my 6 multiplied by my x, so I need to divide by 6. Thanks, Olivia. Negative 30 divided by 6 is going to give me, what's negative 30 divided by 6? What's 30 divided by 6?
5.
5, good. Okay, and I've got a negative divided by a positive. So is it going to be a positive or a negative number? It's going to be negative. Thank you, Olivia. Negative 5. So x equals negative 5. Nice job. Okay. So to recap here, here's our steps. We've got distribute. Then we've got combine like terms. Move our variables to one side. Move our constants with addition and subtraction. And then move our coefficients with multiplication and division. If we want a handy way to remember that, we can remember it as don't call me after midnight. Right? Okay, excellent. What questions do you guys have there? Which step of this is the most tricky? What do you guys think? What's the most tricky step here? The last part, the moving the numbers from one side to the other. Division part. Yeah, you got it? Okay. Okay. Luis, what do you think? Is there a tricky part? No? All right, how about you guys online? Is there a tricky part, or do you guys feel pretty good about all this? Feeling pretty good? Good, kind of. Okay, good. Olivia, that's okay. We're going to keep practicing. If you have a question, though, if one of these steps feels like it's not making sense, please ask so we can make sure we go over that. All right. Let's go ahead and see how we can apply this. Okay, we did this problem yesterday, right? We talked about finding out how many friends could go see a movie where it was the same price at each theater. Okay? What did we have to put together to do that? What are the two things we have to take into account here when we figure out the price? Luis, what do we have to take into account? How much, yeah, what's going to make them both cost the same? So how are we going to make them both equal, right? And to do that, we have to take into account the ticket price and the popcorn, right? So we had to write that equation and then solve that to figure out when that was going to be the same price. Okay, let's try another one like that. Okay, let's try this one. Okay, this one is similar, except now we're going to go bowling. Who likes to go bowling? Who has ever been bowling? You've been bowling one? No, you haven't been bowling? No? Luis, have you ever been bowling? Yeah? Was it fun? Yeah? Okay. Alex, Olivia, how about you guys? Have you guys ever been bowling? Okay. Olivia, was it fun? Yeah, okay, good. Okay, so we're doing the same thing. We're gonna take a class trip to go bowling. And we want to find out how many games is it gonna take at each of these two places for the price to be equal. All right, so here we've got family bowling, where the cost is for each game that we bowl, it's going to cost us $4. And then to rent our shoes, it's going to cost us $1. Then we've got another spot we could go, which is the night owl bowling, And at Night Owl Bowling, the games cost $3.75 and shoes cost $2. Okay, so Stephanie, what are we trying to find out? What's the thing we're trying to figure out in this problem? Okay, how many games does it take for what? Okay, so how many games does it take for the total cost to be equal? Okay, so Juan, if we're trying to find the total cost being equal, what are we going to need to do here then? We want the total cost at family bowling to equal the total cost at Night Owl Bowling. How, in general, like in a big picture sense, what do we have to do to figure that out? Remember what we did at the movie theater? You don't remember? Okay, that's okay. Louise, what about you? Do you remember? All right, how about this? What if I tell you this? What if I say we want to write an equation where we have got family bowling on one side and Night Owl Bowling on the other side? Would that help us figure out, if we set those equal to each other, is that going to help us figure something out? Yeah, okay. Let's figure out how much it's going to cost to go bowling at family bowling. What do we know about family bowling? What do we know?
Each game costs $4.
Okay, so we know that each game costs $4, and we also know that the shoes cost $4. Okay, what do we not know? What's the thing we're trying to figure out here?
The cost to be equal.
Okay, we want the cost to be equal, and what's our variable going to be? What's this thing we're trying to figure out here? How many games? So are we going to need a variable here to represent our number of games? All right, what variable do you want to use? G. Okay, so we're going to have G is number of games. And each game costs $4. And shoes cost $1. Okay, how can I put this information into an expression that represents the cost of bowling at family bowling? Which one of these does the G go with the $4 or with the $1? The 4. Stephanie, why does it go with the 4? Because each game costs $4. Right, exactly. Okay, so we're going to have $4 times our number of games. And now, Luis, what would I do with my dollar for my shoes? I'd add it. How come I'd add it instead of multiplying or something else? I'm going to have to pay for my games, and then I'm also going to have to pay for my shoes, right? So those are going to be added together. How many pairs of shoes am I going to rent? Just for myself. So I need 1, right? Okay. So plus $1. Okay. Olivia, yeah. Okay, so Olivia wrote an expression up here. So she wrote 4G plus S equals C. Yeah, I think that makes a lot of sense. So we've got $4 times the price of the games plus our shoes is going to equal our total cost. Yeah, absolutely, Olivia. That looks good. What could I plug in here? So if I get 4G plus 1 is my family bowling, how could I take what Olivia did here as far as making this a really general expression and turn that into an expression for night owl bowling? Louise, how would you, instead of 4G plus 1, if I plug in my numbers for night owl bowling here, what would you get? 3.75G plus 2, because my games are $3.75 and my shoes cost $2. All right, nice work. Okay, what's next? Okay, so I've got this great equation written here. Now, how do I figure out how many games? Our question up here was, how many games does it take for the cost to be equal? What do I need to do to figure out how many games? Sorry, Lon, I didn't hear you. What did you say? We need to figure out how much it costs. How are we going to do that? What do we need to know?
The next step.
Yeah, okay, what's our next step? Okay, we're going to subtract 2. So overall, Stephanie, what are you trying to do here?
Trying to get rid of
Oh, you're trying to make it too complicated. Just in general, we're trying to solve for G. Yep, good. We're trying to find out how many games we can bowl. All right, and you said for the first step you wanted to subtract 2? No? Okay. What do you want to do for a first step? All right, let's think about our saying. Don't call me after midnight. Do we have anything to distribute? No, we don't see any parentheses here. There's nothing we need to distribute. Calls, combine like terms. Are there any like terms on this side of the equation or this side of the equation? No like terms. So we don't need to combine like terms. The next step was me, don't call me. And that was move your variables to one side. Okay, which side should we move our variables to? Okay. All right, let's subtract 3.75. 3.75. Okay, remember, we're only going to subtract these numbers with the variables here. Our constants are just going to hang out and wait till it's their turn. 4G minus 3.75G. 0.25G. Oh, yeah, isn't that what you said? Yeah, okay. Plus 1 equals 375 minus 375 is going to be 0. That's going to go away. And then our 2 is going to come down here. Okay. What are we going to do next? Get rid of the 1. How do you want to get rid of it? Subtract it. Okay. All right. Now, in this case, our variable's just hanging out. So we're going to drop it down. 1 minus 1 is going to give us 0. So those are going to drop out of our equation. 2 minus 1 is 1. All right, I'm going to write this over here so we have a little bit more room. Okay, somebody online, Alex or Olivia or Michael, tell me, what do I do next? What do I do? What's my last step to get my G by itself? I've got 0.25G equals 1. Yep, all right, Olivia, right, we're going to divide by 0.25, right, Juan, good job. Divide by 0.25. What does it mean to divide by a decimal? That's tricky, right? All right, well, we know on this side, 0.25 over 0.25, that's something over itself, so that's always going to be 1, okay. So we've got 1G on this side. 1 divided by 0.25. What are we going to do with that? Anybody know? Okay, so there's a couple things we can do here. we could pull out our calculator and we can plug this in a calculator, right? We can also think about this a little bit differently. Let me show you guys this. Where's my mouse? Okay, 0.25. If we turn our decimal into a fraction, what fraction is 0.25? Who knows what fraction of a dollar is 25 cents? What do you call 25 cents? A quarter. Okay, so 0.25 equals 1/4. All right, so here we're trying to do 1 divided by 0.25, which is going to be the same thing as 1 divided by 1/4. Do you guys remember when you worked on fractions, that dividing by something is like multiplying by the inverse? You guys remember that? No? Nobody? Okay. So if instead of saying 1 divided by 1/4, I could turn this around and I could say, I'm going to take my 1, and instead of dividing, I'm going to multiply, but I'm going to flip this fraction upside down. So it's going to be the inverse. So I can multiply, but now instead of multiplying by 1/4, I'm going to multiply by 4/1. I'm going to flip that upside down. Let me make that a little bit more legible. Okay, so if I have 1, and what's 4/1? What does that mean? If I have something over 1, if I have pieces that are cut into 1 piece, and I eat 4 pieces, how many pieces do I eat? 4. Yeah, I'm gonna eat 4 whole pizzas. Okay, so 4/1 is just like saying 4. Okay, so this I could write as 1 times 4, which is going to be 4. Okay, all right. So my G here is going to be 4. Hang on one sec, Stephanie. So if G is 4, what does that mean in the context of my problem? So G is 4, so what? Why do we care that G is 4? What does that tell us? Tells us what? Ooh, games don't cost $4. Remember, what are we trying to find here? What? How many games? So G equals $4 tells us what?
4 days.
How many games? Yeah, we can bowl 4 games and have the price be the same. All right, awesome. Okay, so we know that we can go bowling, and we can go to either family bowling or night out bowling. If we're going to bowl 4 games, they're going to cost exactly the same. Okay, Stephanie, you were going to say something else. What? Yes, sorry. I'm having a hard. This fan right here is really loud today. So, 10 o'clock. There you go. Yep. Okay. All right. What do you guys think? So we went through a bunch of steps here. We looked at what we were trying to solve, figured out what we were trying to determine here. We looked at what we knew about each one of our situations. We talked about how do we find our answer. We're looking for when our prices are the same, so we needed to set these equal to each other. We wrote our equation, and then we solved for our variable to find out how many games we could bowl. Okay, lots of steps there. Anybody have any questions on any of those steps or feel like they want to review anything there? No? Everyone's feeling okay? Yeah? Okay. All right. Uh-oh. Okay. All right, let's look at another problem here. We've got another situation here. Actually, let me think a sec. Do I want to go on and do this one? Yeah. Yep, we're gonna do this one. Okay, so we've got this situation here. It says that a lab technician needs 25 liters of a solution. So this is like in some kind of like chemistry lab or something. And we need 25 liters of a solution that is 15% acid for an experiment we're gonna do. But she only has a solution that is 10% or a solution that is 30%. So how are we gonna mix this together and determine how much she needs? Okay, so here's where we are gonna get to this point where